Hello, everybody. Welcome to the session. I'm going to try to keep it about 30 minutes. I have probably 28 minutes of content, but I speak faster than I should, so we should hopefully have more than 5 minutes to have towards the end if you have any questions. We have a mic in there. If you have a question while I'm speaking, I'd rather you interrupt me because it might help people share context. So just put your hand up instead of waiting for me to get to the end. Sound good? I know you're all food comaing, but it'd be great if you got pumped right now. Okay, let's go. So yeah, I'm here to talk about distributed or decentralized data onboarding. Yeah, what do you want me to do? Keep my face, that's so nice of you. Okay, thank you very much. Yeah, here to talk about distributed data onboarding and Data Daos. I realized actually as I was writing the content for this talk several hours ago, I promise, that the D really shouldn't be distributed as much as it should be decentralized. For those of you that appreciate and know the difference, that's awesome. For those of you that don't, continue to use it interchangeably till somebody corrects you. So I'm going to do this through the lens of talking about Slingshot, which is a program that my team has been running for about a year and a half at this point. And really what we'll do is we'll look at the journey of Slingshot and then try to abstract out some components. So I'll try to general case as much as I can for some of the stuff that you learn about, so we can see how we'd like to apply it to different settings. I also want to apologize. I don't normally sound like this, but 10 days of lab week will do that to anybody. So hopefully you'll forgive me for my vocal range this afternoon. So the goal for Slingshot in general is to store important open data sets on the Filecoin network, ensuring that they're preserved for many generations to come. Generally, you should interpret that as a program that lets us onboard a ton of open data to the network and make it accessible for different types of use cases, whether that's research, public good, open data commons, just ensuring that stuff that was generated through different processes in the past is made available in the future, etc. For some of you who haven't heard the term open data before, I'm going to take a second to define it. Open data has a ton of definitions. I picked one from something called the Open Data Institute that sounds relatively like the right place to go to understand what open data is. But I also picked this one because it's the shortest. Every single other one is like a paragraph, and I didn't have space on the slide. So just so you know, open data is data that anyone can access, use, and share. This particular institute is actually set up by Tim Berners-Lee, who's a relatively important guy. But for me, really, 4 key tenets are what you should think about when you think about open data. 1, it should be accessible to anyone. 2, it should be usable for any purpose. 3, it's reproducible. And 4, it's open license. So you can choose to put it wherever you want to. You can share it in whatever way you'd like. Usually you cannot claim it as your own, but you're still able to use it as if it's your own. Today, where do we see it? We often see it come out of governments, historical archives, scientific research institutions, NGOs, NPOs, and other similar organizations. And they mainly tend to store it in one of 2 ways. They either store it in their own infrastructure that's set up like custom bespoke for the work that they're trying to do. Sometimes that's literally like physical infrastructure on premises. Sometimes that's hosted infrastructure on the cloud. Or they'll have agreements with generic cloud providers like AWS, Azure, GCP, who will tend to give them preferential contracts to store their stuff because that's how they make themselves feel better about the work that they're doing. That's actually not true. The reason they do that is because clouds make money on compute. So if you have access to data that is valuable and people want to do computation on, like run machine learning algorithms on or train stuff on, then keeping it available, keeping it cheaply accessible is what brings people to your cloud. And then your cloud can be sticky and keep people there. And so it tends to be easy to use, easy to access, and extremely hard to move. You've often heard the term egress. That's when we need to move stuff around using the internet. Traditional cloud providers tend to make a ton of their money on compute and on networking, and networking specifically on egress costs. So getting it in there is easy, getting it out of there is extremely hard. And so that's really why we're thinking about open data tomorrow, which is using Web3 and specifically Filecoin to access extremely cheap storage that's geo-distributed, has accessibility all over the globe, accounts for changing regulation and geopolitical factors, very easy to track, very easy to build replication, very easy to access and test availability. And so Slingshot really is a program that says, let's make a default or at least an alternative option to traditional Web 2 cloud or thinking the Web 2 space to store open data and bring it onto the decentralized web. So how do we go from identifying open data sets to storing them on Filecoin? This slide you're going to see like 3 times, maybe 4 in this deck, and I'm going to use it as sort of the central theme to drive like how we're chatting about different stuff. Specifically, I want to focus on the second part of this, which is how do we store them on Filecoin. So we came up with this thing called Slingshot. Slingshot V2 is often what you'll hear me referring to when I talk about past Slingshot. V2 was responsible for basically onboarding about 48 petabytes of data to the network, which even by today's standards, if you look at historical all-chain performance, that's about 20% of everything Filecoin's actually ever seen. Currently, we're about 18 petabytes of the network because deals, of course, get renewed. Some don't. Some data is useful to keep, some is not. And so we're about just shy of 10% of active capacity. That data comes from about 63 datasets from different organizations. They include things like Landsat, includes environmental data, includes financial data, a whole bunch of stuff. We ran it for about 18 months, learned a ton of it, learned a ton of things through it, and that's what I'm going to focus on as the data that I'm going to present to you as evidence that we're moving in a better direction. Slingshot V2 is architected to have 2 main stakeholders. We had what we call participants or community members. They were effectively proxy clients. So thinking of them as clients is probably accurate if you understand the Filecoin term of client. And if you don't, I'm about to explain it to you. In the Filecoin marketplace, you have two main entities that transact to make a storage deal. You have a client and you have a storage provider. A client wants something stored on the network. A storage provider is willing to store it on the network. They negotiate, they make a deal, and that's the core value prop effectively of Filecoin is to say, great, you made this deal, we can continue to prove that what you wanted stored is being stored for as long as you wanted with the people that you wanted it to be. And so participants for us, in a Slingshot sense, are like proxy clients for making storage deals on behalf of whoever it might be, in this case us, to store data that we were interested in seeing stored on the network. Storage providers, on the other hand, are the supply side of the market. So people that are able to provide capacity to make those deals. The way the program was designed was that people would sign up, they would create a project. A project was effectively their interpretation of what they wanted to do with a single eligible data set. So there's a one-to-one mapping between projects and data sets. There's a one-to-many mapping between participants or clients and projects. So they could create multiple projects. And we had like a list of eligible data sets. Some of the ones that I named before are part of that. And participants were responsible for the entire process of onboarding. And because they were client proxies, they did literally everything. Like they would go get the original data, they would find a way to make it transformed into something that could be stored on Filecoin. They would figure out who to work with in terms of the storage providers. They would make the deals, and then to us, they would just provide some metadata about what they had actually done. So just to explain that a little bit more with some awesome animations that I'm really hoping I didn't get wrong. A participant would go to the original data, grab it, find a way to transform it, get it into a car file, take it to a storage provider, say, here's the data, let's make a deal in the Filecoin network sense. They would then update the status of the deal to an app that we were using to track the program to say, hey, I made these deals, this is the metadata of the deals that I made, and then we'd go look at that app and say, cool, and then we could test that by looking at the network, because the benefit of having a blockchain is literally you can see what happened. And so we could validate that that was the work that was done, and then we'd use that as a mechanism to pay out rewards for participating in this program and doing the work that we wanted you to. This got us like far, but not as far as we wanted it to. And so some of the main takeaways that we had from this. So number one, pretty much everybody participating was a storage provider, right? Like they're the ones that are the savviest about what's going on in the ecosystem. They know when programs exist. They know how to take advantage of stuff that's made available to them. Onboarding itself is actually really hard. It takes a lot of work to go from the original data set to getting stuff onto Filecoin. And so there are local experts in doing that. Moving data is expensive. So if you're at the site at which the data was transformed, very great. Easy, make deals right there. I don't care about making deals anywhere else. Why should I? There's no reason to. It's not rational. And the way the reward structure was set up, the rational outcome was actually not aligned with the mission of the program. It was not resulting in good distribution of deals of well-produced, well-transformed data, because there was no reason to. Like you could just get by with the easiest thing, the cheapest thing, and like localize it to where it was most convenient. Second was that we really need standards in the community, especially in like an open source ecosystem where multiple people are building multiple products. The way in which you ensure there's a high quality of work is by creating, setting, and then aligning and maintaining standards, none of which we were doing when Slingshot started, some of which we were doing when Slingshot ended, a lot of which we'd like to be doing, and I'll chat about that a little bit more. And then the third is that, in general, data onboarding requires significant coordination. especially when you're talking about different types of stakeholders. And if there's a shared goal, like there's a shared program and a shared community, then the coordination expectations are even higher. And just expecting that people will fall in line and doing what you want them to do because monetary rewards are set up correctly is not necessarily the best outcome. And so from this, back to the slide I told you was coming. How do we go from identifying open data sets to storing them on Filecoin? Really turned into a question of how do we engage the right sets of stakeholders in the data onboarding process? So how do we differentiate between these different steps that exist, identify the right people that can actually do them? How do we incentivize the engagement and ensure that the output is high quality? And then how do we use the learnings that we have to shape standards of how data should be processed and onboarded to Filecoin? Before I go into the real meat, people doing all right? Good? On the same page? Okay, now it's gonna go like real speed of light. So if you're not following, stop me, because otherwise you're just gonna be gone. Okay, cool. So let's talk about the data. I wasn't kidding. Let's talk about the data onboarding process. So right at the top, right, you've got data owners, the data gets onboarded, great, it ends up with storage providers and Filecoin. What does onboarding actually include? This is grossly simplified, but roughly I would say getting access to the actual data, transforming it into something that can be stored on Filecoin, distributing it to where it needs to be stored, and then making the deals on the network. The first two, we sort of loosely talk about more as data preparation. The third one, the distribution, can be thought of like moving data or data movers. And then the last is sort of the actual deal-making mechanisms that take place of automating the process or in some way ensuring that at scale, you can store stuff on Filecoin. And the reason this matters is because most data sets are like hundreds of tebibytes. Each tebibyte on Filecoin is 32 deals. If you're storing something like 10 times, that's 320 deals that you have to manage for 1 tebibyte. If you've got 10 tebibytes, 3,200. The numbers just keep going up, up, up. And in Slingshot V2, I think we ended with close to 2 million deals. So not having proper automation and management of deals is not to be underestimated. And in essence, we're like, great, we have these different stakeholder roles. How are we going to align our programs with these and get better learnings and takeaways for what makes each of these groups successful, with the hidden eventual motive that the market actually starts to mature and stratify and start to build businesses on these things. And we sort of encourage that and enable people to think further in more specific ways, in more depth, to produce useful content and useful services. So that we introduced Slingshot V3. So this was announced, I think, right around July 4th. This is sort of our big evolution of what Slingshot was designed as before to align better with what you just saw in the previous slides. And for the 4 of you that are keeping up with me, that's exactly sort of should make sense with where we're at. So the intent behind Slingshot V3 is community program for developers, data preparers, and storage providers for preserving open data sets on the decentralized web forever. It sounds a lot like the original mission because it's the same dude and the same set of things and the same problem, but that's okay. And the main sort of changes are that we're decoupling the data preparation from the actual storage, and I'll show you what that looks like. We're introducing standards for distribution and preparation of the data, and we're actually introducing a new component in Slingshot, which is our own specific deal engine that is optimized for search providers to ensure that redundant work is not done, and work that is done meets a high bar and is something we can double down on. So what does this actually look like? So if you look at Slingshot V3, you can participate today as something called a DP, which is a data preparer, or a storage provider, an SP. So I'll be using the terms DP and SP moving forward. DPs select data sets that they choose to download, process, and get the metadata for, as well as the actual data for, and they're responsible for getting those ready for deal making effectively. And SPs are responsible for obtaining that data and saying that, hey, I'm ready to make deals. And so you can see something that was defined in a single value flow already has 2 different, very distinct operational roles. You might be the same entity behind them, but we found a way to effectively delineate differences between what we expect. And in the first phase of Slingshot V3, we're chasing down all of AWS's open data registry. So they have about 175 or 178 data sets or something like that. It's about 35 petabytes of unique data that we're looking to store. Should result in a chain footprint of about 350 petabytes if everything goes according to plan. Of course, we're sending out deals as verified deals, and we're doing a bunch of work around quality of work assessment, KYC, and sampling. I'm not going to have time to go into that last bullet, but it's a really important component of what we do. So if you're interested in chatting about that further, find me or find Caroline on my team, and we'll talk about it further. Okay, it's about to get way whacker. Okay, we have some questions. Can you use a mic so the recording catches it?
What's the relationship between the replicas and the storage providers? Is that, can all 10x replicas exist on one SP, Or is that 10 SPs?
Great question. And thanks for allowing me to get a water break. I appreciate it. If anybody else has questions, please hold for about 2 minutes because that's when I'll need my next sip. You're totally right. We don't want stacking of replicas. And that's part of why we introduced the centralized deal maker is because we are able to now do KYC on individual storage providers and ensure that when we do send out deals, we're striping them across so that no more than one replica ever hits one storage provider. So our specific deal-making policy is that each city, which is a proxy for data center, can only have one replica of data. Each country can at max have 3. Each continent can at max have 4. And each piece of data can at max be replicated 10 times. And on the other side, what we're doing is we're tracking a mapping between storage provider entities or organizations versus actual IDs to say that an org can have up to 2 IDs as long as they're in different cities, countries, or continents. Yeah, it's cool. It's actually the state of the art, basically, for the network. And so the way this works, we increased a whole lot of boxes compared to the previous slide, but I promise it's worth it. I'm also going to do like 18 arrows or some shit, so please follow along. So data preparer goes to the source of original data and does a bunch of transformations on it. We use a tool called Singularity for that. They update in the Slingshot app saying, hey, I did a bunch of transformations. I'm ready to make deals. They also produce a bunch of metadata based on a standard that we set that we require in terms of what's actually been done and what the data is. That gets updated and uploaded to like a metadata store. Currently, we use web3.storage. From the metadata store, we're also independent of the metadata store, Slingshot admin team or ops team is still able to track what's happening because data preparers are supposed to keep their progress locked into the app, and so we can follow along with what's happening. The deal engine that we have, that we're calling Spade, has the ability to read in from the metadata and see what's actually eligible for deal making, and makes that available as stuff that storage providers can make deals with from the deal engine. One of the unique things about this deal engine compared to other deal engines or brokers that you may have seen is that deal making in Filecoin tends to be client-driven. It's a client that makes a deal proposal to the storage provider. Our thesis is that the most knowledgeable person in the room when it comes to deal making is actually the storage provider. Like they know how to optimize their resources, their network, their compute power, the access to the other deals they have, the flow that they have. And so in our case, the storage provider is responsible for actually actioning the request for deal making. And so in this world, effectively, the storage provider is actually connected to the data preparer. And that's a choice we made because we know most of the time it's actually the same person. But even when it's not, there's a myriad of ways, including it's the back of my shirt, for them to get matched, for the storage provider to actually figure out where the data lives and get at least one replica up. And then that storage provider would come to the deal engine and say, hey, I'm ready for a deal. I have this piece of data. Give me a deal proposal for it. And we'd give them a deal. Another storage provider may come along and say, I also want to make a deal for this. I'm eligible for it. I'm based in a different city or a country. I'll retrieve that data from the first storage provider. Or maybe I'll go back to the original source. I don't know, kind of up to you. But go to the storage provider, get the piece of data, come back to the deal engine and say, I'm also ready. And we keep doing this. We keep enabling this for up to those 10 replicas based on the policy that we have. And then on the side, we have this piece of software called the validation bot. For those of you who've been around for a while now have heard the term deal bot. Validation is basically our sort of evolution of that, where we get to test quality of work and quality of service for the individual storage providers and build just a ton of super valuable reputation data. And what we're doing there is we're testing SPs for things like, are you running the indexer? Are you actually serving retrievals over different types of data transfer, like HTTP, Boost? Are you actually enabling us to have open retrieval for this data, 85% of the time, or like some reasonable threshold? And by this way, we can actually give feedback back into the deal engine and say, hey, Spade, stop sending out deals to this SP because they're not complying with your policy. They're not complying with what you expected them to. And so we created a very tight feedback mechanism that enables us to define policy and then actually follow through on it by using future deals as the actual incentive and the carrot for high quality work and compliance with policy. That's a lot. Did you guys get that? Any questions? Wyatt has a question? Cool. God bless. Okay. I don't know if I want it. Okay. Allow it.
Yeah, one question. The validation bot data, the output, is it something that we can consume from other projects?
Yes. We'll talk about that afterwards.
Okay. Thanks.
Cool. Easiest question. Phil? Mike, please.
Is Spade exclusive to Slingshot, or are you going to try to outsource it to other things too? And also, does Spade have to use Web3 storage? And why does it need to talk to Web3 storage in the first place?
Spade is not exclusive to Slingshot anymore. Part of our branding into Spade is to make this a multi-client, multi-tenant service. So in fact, Reba is in conversations with some of the most popular people at Phil Lisbon who are interested in working with this tool and onboarding their data using it. You should think of it as a client agnostic, but really SP-driven deal engine. And so as you see, we've got a bunch of different types of on-ramps into the network. For example, Estuary, they all sort of have their own niche. To give you a concrete example, Estuary gambles on sending data at the point in time at which the deal needs to happen and initiating deals from the client side, and the data transfer being via the Filecoin network. Spade is in many ways the exact opposite, which says that the data should have been distributed async. There was no need for the client to initiate the deal, and there was no need for the data to have flowed over the Filecoin network. And so it's SP-driven deal making, open to multiple clients in the very near future. And in terms of the Web3 storage, no, that's just an example of a store where we might have kept metadata. It is valuable to have a metadata store for the engine to function, but it also has its own DB. So we plan on opening up an API endpoint where theoretically, like a client could just push data into our DB and say, hey, here's what I want you to store for me. Cool. You have a question on this?
Can you give me some examples of the data that is in the metadata store, just so I understand?
Totally.
You know, if we're a map of the SPs or if it's ACLs on a file system?
Yeah, it's actually data about what's in each CID. So the funny thing about Filecoin is that we treat everything with hashes, right? So everything comes in and gets transformed into a hash of the original file, but nobody's actually tracking what went into that hash. So we actually are building a standard today, partnering with the Bacalhau team and a bunch of other teams in the network to set the standard for the first version of what's getting indexed about what goes into a file. So inside a car file, we'll track each individual file that's been put in along with their associated CIDs, the directory structure along with their associated CIDs so that we can support, yes, exactly. It is such a massive gap. It's shocking that this is what it came to. But I'm really excited about it, and I think it's going to be game-changing in terms of our ability to serve search engines, to serve partial retrieval, to actually make stuff stored on Filecoin useful in specific use cases. Great. I appreciate the double thumbs up. Triple, actually. That's good. So really, the big thing that I want you to leave with is, as part of this transition from Slingshot v2 to v3, what we did is we went from decentralized communities of data onboarders, where we were trusting people as proxy clients to make decisions for us, to a community of decentralized data onboarders. So one community, lots of data onboarders. Cool. Back to this slide. So how do we go from identifying open data sets to storing them on Filecoin? And I promised that I would talk about Data Daos, and this is where we transition into the second part of the talk with a nice 4 minutes to spare. But I started late, so I'm going to go late. Sorry. I want to talk a little bit about specifically the first part now, which is how do we actually identify open data sets? Today, we have what we call a deep dictatorship, which is where you accept me as your benevolent dictator. I pay, so I pick. Very simple. Not a good model. What we'd like to get to is curation of data sets in a decentralized mechanism or decentralized manner where different people get to influence what we're choosing to store. We support distributed decision-making mechanisms, and we have some way to ensure that that work being done is long-term sustainable. So there's some sort of long-term regenerative value for involved stakeholders. They're rewarded for making useful decisions for humanity, for this community, for society, et cetera. And so what are we going to do? Well, we're going to start transitioning Slingshot into some sort of like data preservation DAO. And the way we're going to do that is by first introducing governance for dataset curation. That's going to be like our sort of stepping stone towards actually like running this thing as a proper DAO. And how we're going to do that is by taking lessons from other DAOs, really, and other things we've done in this ecosystem. I know RG's in the room. Like, we're definitely going to implement some things around like working groups based on what we've learned in Filecoin Plus. I love Filecoin Plus. And we'll be taking some of that stuff and applying it towards like structuring decision-making bodies that can efficiently transform Slingshot into a more community-governed version of a preservation DAO long-term. And so we're working with a team called Equity, EQTY. They're technically in stealth mode, so for those of you watching the recording, just skip the last 30 seconds and don't listen to them again. For those of you in the room, cool startup coming to help with DAO tools, yeah! And so they're going to facilitate, having proposals, multi-staging those proposals, facilitating voting via representative, delegate, et cetera, basically providing a full toolkit for us to use sort of Slingshot as an example, like a canonical reference of progressively decentralizing something from going from a single organization-driven program to being a community-governed program where we can leverage this set of things and paint a really clear picture of how somebody could do this and follow in our footsteps. I think there's a ton of different programs in our ecosystem that would benefit from this. And so we'd love to have you involved if you're watching this, thinking about ways in which you could leverage what we're working on. Specifically, we're working towards having a 2-milestone launch. The first one would basically just have very basic sort of how would we form the working groups and the structures, how do we originate proposals to those working groups, how do we actually make decisions on curation, with the second sort of V1 actually including influencing the policy, like the thing that Phil, you just asked me about, where it's like Slingshot, how do we actually use the deal engine, why do we use Web3.storage, or the question I got from, I think it was from you, right, on how many replicas and stuff like that. Theoretically, we just decided that was a good idea and we just went with it. But in a community-governed version, we'd want the community to decide. And there's some complexity there, right? Like if I asked Julian, who runs a storage provider business, how many replicas, he'd say 50 replicas sounds great on one machine. And that's not necessarily the best thing for the rest of the world, but it'd be really good for an individual storage provider business. And so ensuring that we're actually giving voice to the right sets of stakeholders, creating like definitive and useful voting mechanisms for actual useful output for Filecoin and its mission to be the store for humanity, mechanisms for standard settings, standard altering, mechanisms for grievances, feedback, etc. So that's sort of the stuff we're like working on in like the next like couple of months. And then, as I'd said before, we want to use it as like one implementation experiment that we're really putting a lot of resources behind so that we can build tools that can be used by other programs and sort of evolve Slingshot itself to go beyond just like our team at PL and get it out to be a truly community-governed thing. So what does this mean for you? If you're a storage provider, you should go join the Moon Landing program. Caroline will be talking about this in a couple of hours in this room, and on YouTube you should be able to find her talk. But this is the easiest way for you to really become part of the program from the supply side first, because you're already set up for that. If you're interested just generally in the data preservation of open data sets, a really good place to start would be to participate in Slingshot V3. Like join us as a data preparer, get familiar with the ecosystems, understand how the tools work, how these pieces fit together. And if you're like even more broadly interested and don't really care necessarily about one individual implementation within it, then just join the conversation generally. We're not cool enough to have a Discord yet, but we're working on that. In the meantime, you can join us in the Slingshot channel. It's an open channel in Filecoin Slack. You can share your ideas and collaborate. I'm getting a big thumbs down at the back of the room from Reba. Anything you wanted to add? No Discord ever. Sounds good. You can't have Discord if you're trying to build a cord, right? Anyway, other than this, I mean, a lot of people might just want to chat more generally and broadly. You're welcome to reach out to me anytime. And with that, yeah, thanks so much for your time.